Hi everyone, this is Michelle, and I will be giving an overview of how to combat AP Calculus AB in my class. As a teacher who studied the rigorous IB diploma program in an American international school, our ultimate goal is to help you achieve the best results in your AP and school exams. In this AP Calculus AB course, we will be covering the test-centered questions, and this is the structure of the test. The first section is the multiple choice question, and the second section is your FRQ, also known as the free response question. These are the number of questions, the exam weighting, as well as timing. In this Calculus AB course, we will be covering over 8 units, inclusive of limits and continuity, differentiation, the definitions and fundamental properties, as well as implicit and inverse functions, contextual applications of differentiation, analytical applications, integration and accumulation of change, differential equation, applications of integration, and many more. These are the objectives of the free response question. We will conduct a lot of practice, including how to implement mathematical processes, connecting representations, justifications, and communication with notation. Moreover, our lesson will be goal-oriented by helping you to achieve the highest grade in your AP test. To achieve this, we will focus on intricate applications, long word problems that most Korean students face difficulty in, as well as your weakest sections. So first, let's take a look at some example questions. This is the first key concept. You have to recognize the connection between differentiability and continuity, analyze functions for intervals of continuity or points of discontinuity. Applying this concept, let's take a look at this question. The graph of the piecewise defined function f is shown in the figure above. What are all values of x between -4 and 3 at which f is continuous but not differentiable? So if this type of question is quite new to you, rest assured, because we will be covering all the foundational concepts step by step in this course. So next, let's take a look at our free response questions. People enter a line from an escalator at a rate modeled by the function r given by such equation. The question is, how many people enter the line during this time interval? And how many people are in a line at a time t equals 300? And for C, what is the first time t that there are no people in line for the escalator? And also for part D, we have to justify our answer. So next, this is the solution for the question. We have to take the integral from 0 to 300 and set the equation to 270. According to the model, 270 people entered the line for the escalator when we input these numbers into the equation r. And for part B, we simply have to add 20 with r minus 0.7 between the intervals of 0 and 300, which is equivalent to 80. And next, for part C, based on part B, the number of people in a line at a time t equals 300 was 80, and therefore, the first time t that there are no people in a line would be 414.286. And lastly, for option D, the total number of people in a line at this time interval can be modeled by this equation. And knowing that, we can find T1 and T2. We can conclude that the number of people in a line is the minimum at time t equals 33 seconds when there are 4 people in the line. To conclude, our process is very easy. Through the course content, you will gain knowledge and will focus on your individual areas of weaknesses to finally result in your highest achievement. Thank you for listening, and find Michelle. I'll see you guys in class.